Hello, everybody. Thank you all for joining this webinar today. Today, we will be talking about the ambient noise sensor placement and the recommendations for this for automated volume control with PRAESENSA. Well, as you can see on the next slide, the webinar is being recorded today, so if you afterwards want to review it, you can look at the recording. It will be distributed after the webinar with a direct link. If you have any questions, please remember them, save them for the end of the presentation. There you can put them in the chat box, and then we will go through them at the end and try to answer them best we can. So you can find the chat function in the right bottom corner of the user interface of the WebEx. Please ensure that you are choosing the all panelist options so that both presenters see the questions so we can go through them in the Q&A session. So today myself, Maarten Winks, Marketing Manager for Public Address and Voice Alarm in EMEA, and I am joined today by Oliver Zaam, who is Director Application Design. And Oliver will tell us a lot about the ANS sensor placement. So Oliver, I would like to invite you to run us through the presentation.
Perfect. Thank you very much, Martin, for the opening speech here, and welcome everyone to this webinar. I hope you can hear me.
Yes, Oliver, I can hear you.
Perfect. So then my audio settings are okay now, as I had some problems earlier. But hey, we're an audio company, so we solved it. Welcome to the webinar. Let's have a look into a topic where of the PRAESENSA automatic noise sensor and the volume control in PRAESENSA. So we received a lot of questions here. How does it work and what does it mean for designing a system with these noise sensors, and where to place them, how many of them? So we tried to shed some light on this, and we will look into it. What is a sensor? What does it do? How does it work? What are maybe some general requirements? How to place the unit and where to place it? And also then give some general recommendations, how you can come to such a recommendation when you design your projects, when you want to make a proposal to your customers and for your project designs. And finally, of course, we will reserve some time for Q&A in the end, whatever will pop up here in the chat. So let's start. Let's have a quick recap about the function itself and what it does and how it does. First of all, as said, we have our PRA-ANS as an ambient noise sensor to monitor our background noise levels in a certain environment where we want to install our public address voice alarm system. And the information which we detect with the sensor is used to do some automatic volume control. Finally, the device uses two different modes for its operation. So one thing is quite simple. It's called sample and hold mode, and we can use this normally for a live speech, for a live announcement, or when we want to broadcast pre-recorded messages. And so in those cases, the noise level is continuously detected, it is sampled, and also important here, and I don't know if it is on a later slide again here, but just to name it again, we do not use the audio signal itself. The audio signal itself is not transferred from the noise sensor to a central unit somewhere else in the installation. That means you can also not listen into the zone by hijacking the system, so to say, and detecting here some real audio information. The audio stays in the sensor, and the sensor is communicating with our PRAESENSA electronics just via control data. So the processing of the signal is done in the sensor, and it's pure data communication without audio on the line between the sensor and the central electronics. So we detect the noise levels, we detect acoustically how loud it is in the zone, and finally, once we release the live speech or the pre-recorded messages to be broadcasted, then it gets frozen, so to say, on a certain level. It is broadcasted on a level which is defined on the noise which was detected until the broadcast starts. So we will here, yeah, broadcast it accordingly with a detected thing. The other thing is the so-called tracking mode, which we can use for background music. So continuously tracking the noise level in the zone and to adjust, so to say, the background music level here or some background signal level in the zone to make sure that we are here always on a convenient level to create the desired effect by broadcasting audio continuously into the zone, and that the noise does not really cover the audio signal which we would like to broadcast here. So here it gets a little bit more critical because we need to differentiate between two continuous signals, the noise which is present and the continuous, let's say, used signal here, the music signal. So of course, if we produce our own continuous signal here, it should not lead that it is somehow considered as a noise signal and should lead that we have a continuously increased volume here. Here it's called to prevent volume runaway. Okay, so two different modes, two different things, how the sensor works. In general, of course, even for sample and hold, I mean, you should look into the zone where the system comes in place and what would affect, so to say, the detected noise level. If you have some local sound noise sources like an exhaust of air condition, a vent outlet, or any machines specifically, but they produce noise only in a certain part of an area, but not affecting the whole zone. Of course, it would be not optimal to place a sensor here right next to such a noise source because you would detect a too high noise level, meaning the audio broadcast in the rest of the zone might be too loud. So you would detect, so to say, a false information. Yeah. So this should be avoided. Don't mount the sensor too close to a noise source which is not relevant, so to say, for the complete zone where the sensor has an effect on the broadcasted audio levels here. So in general, also not close to a specific loudspeaker like it is shown here on the right hand side, because also the loudspeakers would be, so to say, a discrete sound source. And in general, you could say the noise sensors should be mounted in the so-called diffuse sound field of the zone, the diffuse noise sound field, which is our reference how to influence the level of the broadcasted audio signal. This is in particular, of course, important when we want to use the tracking mode, because also here, as we said, you do not want to have the noise sensor and the resulting level of your signal being influenced by the loudspeakers broadcasting the background music signal here. So also here, the sensor should be in the so-called diffuse sound field. And I made a little visualization here, meaning don't go too close to a loudspeaker. Too close will be explained a little bit later what it means. because then you would be in the so-called direct sound field of the loudspeaker, and this is where you do not want to be. You want to be in the diffuse sound field in the area which is indicated here on the right hand side by the green areas. If you have a loudspeaker which is mounted here on the lower left position, for example, a column loudspeaker aiming sound into the zone as indicated by the pink arrow. And so wherever you mount your noise sensor here to level the background music distribution, it should be placed somewhere in the green area and not too close to this, in that particular case, column speaker or loudspeaker in general. So stay in the diffuse sound field where the sound pressure level is more or less evenly distributed throughout the whole zone. And this is leading us already a little bit into the area of acoustics, as you can see, because we need to consider here some basics to consider what is my direct sound field, what is my diffuse sound field, where should I place the sensor finally. So let's have a little bit, a quick recap here of basic acoustics. Yeah. So when we look into sound in a room, and the room has a certain reverberation time, maybe you have people on one side here talking, and they listen to someone speaking live or also through a loudspeaker. So you receive a direct sound. And of course, the same sound source produces also diffuse sound, which is also based on reflected sound things here. So that goes via different surfaces, ceilings, walls, whatever, depending on the acoustic treatment of the room. The interior architecture is important, how much reflected sound you get, how you perceive the room. When we look at the direct sound only, and you all know this from some basic saying, whenever you have a point source, so to say, that the so-called direct sound is decreasing with 6 dB by doubling the distance. So when I start somewhere at my loudspeaker at maybe 80 dBs here on the left hand side, and I increase my distance from 1 to 2 meters. So in a pure direct sound field from a point source with my sound pressure level drops by 6 dB. So the further away, the lower the level is which I receive from this point source. Now we come to this effect that my sound source is not in open space, not in an anechoic chamber, so to say. We are in a normal room, at an airport, at a railway station, wherever you are with your sound source. Then you get also the diffuse sound, which is reflected by the walls, by the ceiling, etc., by the floor also. So in an ideal room, so to say, or in a theoretically ideal room, so to say, you would have here an even distribution of these um, reflected sound things depending on even absorptive and reflective materials in your room. Meaning at a certain point of where you are in a certain distance from your sound source, the diffuse sound field should be the same, so to say. And normally this is, so to say, the characteristic of the room is here described by the reverberation time. The reverberation time is defined as a time where your level of sound is dropped by 16 decibels here after you switched off your sound source. And then you can say, okay, normally, let's say dry rooms, how we call this, with a lot of absorption, a short reverberation, are maybe classrooms, offices, primarily for speech distribution speech broadcast. We are below 1 second. In a concert hall, depending on the type of the hall, the type of music you want to listen to, you prefer a little bit longer reverberation times to get a little bit more volume also. So also here, reverberation is not per se negative. It can also be very beneficial. I mean, even in a church, when you listen to an organ concert, for example, you love to have a longer reverberation. So yet you have really the feeling that it is a big sound in a big room, in a cathedral, etc. So just some typical values for orientation. When we look into this behavior, and we said again, in a kind of ideal room where all these reflections contribute from all directions in a room by the same way, theoretically, we would have our diffuse sound field on a certain level, depending on how much reflections we get, and it should be equally loud everywhere in the room, as long as I do not have my get too close to my sound source. So when I have those two fields here, which are indicated by the two orange lines here, my direct field decreasing with 6 dB per doubling the distance, and my constant diffuse sound field on the other side created by the reflections in the room, I come to a certain point where those two are equally loud, and this is called critical distance. So as a total result in a room, and that's all what we all know from our own experience, I can be close to a sound source, to a loudspeaker anywhere. It's loud. I walk away, and at a certain point of time, depending on the reverberation in the room, it might not get lower in volume. It stays on a certain level, and then I'm getting to this point where I go to the critical distance and beyond. So this is more or less the ideal case under, let's say, complete statistical reverberation in my room. And brings us back to what we said in regards to our noise sensor placement. So when I talk about my noise sensor placement, I should be in this diffuse sound field beyond the critical distance, to make sure that I really detect the sound pressure level of my noise, of what is as diffuse sound in the room, and not the direct sound of a discrete source, which is only, let's say, effective and valid in the proximity of the sound source itself. Good. When we take this into account, let's go back to the placement recommendations. And I miss a T here in my title. Okay, we will correct the slide afterwards. So we take into account to derive, so to say, this distance, because normally we get now the questions, of course, okay, but how far do I have to go away from my sound source? What is my, where does my, let's say, green area start where I can place my noise sensor? This is the question which we have to answer here. So, and the minimum distance, as said, should be beyond the so-called critical distance. The critical distance depends now on a few parameters here, which is first of all the volume of the room. How big is my room? The room is in that case, if it is maybe an airport terminal, to stay to this example, of course, not the complete terminal. You should consider only, let's say, the relevant volume, maybe of the gate area, which is your acoustic zone, which you want to control, and not the complete building. The same is valid for the reverberation time, the RT60 of my room or of my area, which I consider as one acoustic zone. And last but not least, the so-called Q factor, the directivity of my sound source, or also my noise source, so to say, which distributes sound into the room. If I have an omnidirectional source which distributes the sound equally in all directions, yeah, it could be a very small ceiling speakers which have no directivity, for example, then the directivity factor is more or less 1. So it distributes all the energy equally in all directions. And here we also have to see the microphone of our sensor is also omnidirectional. So also microphones have a directivity or can have a directivity, but the sensor is omnidirectional. It detects sound from all directions. Normally it may be mounted in a ceiling, so in the hemisphere below the ceiling, so you could say the sensor detects sounds from all directions equally loud. So that brought me to a chart to make it a little bit easier here, so to say. Um, we took this formula which I showed you before. We said, okay, what could be my typical room volume? Let's start maybe with about 100 square meters on the left side here. And let's make our rooms bigger and bigger and bigger, bigger and bigger up to, we just picked a number here, 19,400 cubic meters. On the same time, we can have a reverberation time, which we put here on the vertical axis, and we start with dry rooms, as I called them, maybe offices and other spaces with just 1 second. And we went here up to a typical average RT60 of about 4 seconds as a maximum, which is already very long if we want to talk here about speech broadcasting and still want to achieve also a certain speech intelligibility. Then 4 seconds is already a pretty reverberant room. So when we look into this, then you could say, okay, these colored areas here are indicating a minimum distance what we should keep our PRAESENSA noise sensor away from a sound source. Yeah. So the combination of room size and reverberation time gives me already an indication how far I should stay away from the noise sources or the signal sources which I want to influence with my noise sensor. So very simple. If I have a small room with a short reverberation, I can stay away here, let's say a meter. I can stay away a little bit further away with 1 to 2 meters. We can see here also the smaller the room, or the other way around, the larger the room, the longer my reverberation time. I should stay further away here, and the shorter it is, no, the shorter the reverberation time, sorry. That means my direct sound field goes further away. So that's one thing. And as said, we start here with omnidirectional sources. When we say now, okay, my sound source is not omnidirectional, it has a certain directivity. So when I want to see how far do I have to stay away for this continuous mode tracking where I want to influence the background music level, and I should not have a direct influence of my loudspeakers broadcasting the background music, I should stay a little bit further away than just for an omnidirectional source, because my loudspeakers broadcasting the music have a certain directivity. It might be ceiling speakers, and a single ceiling speaker might have a pretty low directivity factor of 1.4 maybe. So then I should stay about 1.4 times this minimum distance, which we saw on the slide before. If I have a projector loudspeaker which has even a little bit higher directivity, so meaning my direct sound field goes a little bit further, I have to go a little bit further away to come into the diffuse sound field, meaning I should stay away 3 to 4 times the minimum distance which we saw on the chart before. The Hemi is also in the same category with about factor 3.5. A column speaker is intentionally used because it has a higher directivity. We want to go further with the direct sound when we broadcast an audio signal into the zone. So of course, then my noise sensor should also be further away to stay out of the direct sound field, which is produced by a column speaker or by a horn loudspeaker, which you see underneath here. So then we should stay at least minimum, let's say about 6 times the distance away, which we have detected from the chart before based on the room acoustic conditions, reverberation time, and room volume. And of course, all the things what you see here are first of all only valid for a single loudspeaker. So if you have now multiple loudspeakers, you should take this into account here. Then you should take this into account per speaker. So you should stay away from each and every speaker the defined distance here. Leading us to some further recommendations. When we have high ceilings, bring it further down, get closer to the audience where you expect the sound to be, let's say, affected. Where do people listen to it? So get a little bit closer to maybe approximately 4 to 6 meters above the floor only. When we, per design from our system side, from the electronics side, how we can program these units, the maximum is to use 4 sensors per zone. Also here, I cannot give you a fixed rule how you would say now, okay, do I need 1, 2, 3, or 4 sensors in a zone? First of all, also here, have a look at the zone yourself. Have a discussion with your customer, with your system integrator, or have an imagination yourself, so to say, how the zone looks like. Is it distributed noise sources? Again, airport terminal, for example, gate area. The biggest noise source there might be people chatting with each other, creating noise by going around with their baggage trolleys or whatever. Those will be all over the place. So you will have a large distributed noise source, which is maybe affecting your background noise level here. And if you want to detect this equally with the noise sensors, yeah, you may place 1 or 2 sensors in the zone, but it may not make a big difference to place even more sensors because the noise level detected in one area is not much different to what you would detect in another area of the same zone where you want to broadcast your signal. But if you have a lot of different noise sources which may have an effect on the zone again where you want to broadcast your signal, then make sure that you detect, so to say, the relevant noise sources, defining the loudest noise which may affect the zone broadcasting as a complete zone. So there is no fixed rule. It is a little bit really the experience and the common sense which helps here to have a look at this. If you are in doubt and you would like to discuss this, feel free to reach out to the SBD colleagues in the CSOs or to the MKA team in the locations where we have our colleagues located. We are more than happy to give you here some guidance or some quick indications how we would maybe do this from our point of view as a kind of recommendation. When we again see here the automatic volume control for background music, again, consider your loudspeakers as source and stay away from their direct sound field. And Of course, in other things, again, also here, make sure that you see, okay, what could be my worst case? What is if noise sources are switched on and off, machines, ventilation ducts, whatever. And also here, consider this for the mounting position, but also maybe for where do you detect noise anyway, which may become relevant for your final solution. This was mentioned already, the critical distance, meaning what is my room acoustics? Don't go too close to your sound sources to be in the diffuse sound field. And of course, when you have multiple zones, areas with individual broadcastings, make sure that your sensors are really in the area where the relevant signal is broadcasted. It was not a typical type for automatic volume control, but I can tell you yesterday evening I was at an airport here in Germany, and they made loud announcements for another gate in the gate area where I was waiting to board my flight, and it was definitely very confusing to get loud and clear announcements for something which was completely irrelevant for your area. So whatever we do here, and we want to increase or decrease the volume of a call to a zone, make sure that you pick up, so to say, the right noise, not anything what is affected from adjacent areas here. And this was mentioned already, so discrete noise sources which may have an, let's say, outstanding effect on a smaller area, but not for the same zone. For the complete zone you influence here, make sure that you do not use them as a reference only. And yeah, when we are outdoors, or I would say even with these high ceiling things here, get the noise sensors also here into the relevant positions to detect the noise where it is also, let's say, relevant for your listeners. This was more or less the overview to give some general guidance here to show you what are the, let's say, relevant factors which you have to consider when you design such a system. And I would say, let's have a look at the chat here, which questions we may have already, and let's answer your questions now. I have to
Okay.
see how I get
Thank you,
back.
Oliver, for the presentation. Very, very interesting. So let's have a look at the chat box. What questions are posed here? So there is a question here for slide number 19. The mentioned speakers are not per definition Bosch speakers. That's a question.
Definitely not. So I mean, of course, I took here some Bosch speakers as reference to calculate these factors, which I showed, but you can expect that even competitor speakers, where they have ceiling speakers, column speakers, they have similar, let's say, acoustic behaviors, and then it is the same. So it's not only for Bosch speakers, no.
Mhm. Okay, thank you for this. Then point 3 on slide 18 says sound sources. You mean speakers connected to the system, correct?
Wait a second, which slide? Let's go back. You mean
18,
this one? Slide 18.
point number 3.
Yes, 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 yes.
Yeah, because that's a closed system, right? The sound sources are controlled by the PRAESENSA system, and the PRAESENSA system takes the input of the ambient noise sensor to
Yes.
tune the volume level. So this is a
Yeah.
this is a closed system. Yeah.
I mean, again, here, first of all, sound sources in general. So even if I have a machine producing sound or noise, and I do not want to consider the direct noise field of this machine, but also maybe how the machine affects my whole zone. Also, I should, as it was indicated on the other slide, I should stay away from this so far that I said, okay, the diffuse influence, so to say, of this noise source should be my measure or my basic input, my parameter to influence my signal here. But of course, we do not know the directivity of such a source in most cases. So here on that slide, as we started to look into this continuous mode operation, where my loudspeakers are the source for the background music, and those speakers are connected to my PRAESENSA system. Yes, here the sound source is our loudspeakers with the factors which I showed them here on the next slide.
Mhm. Okay. Good. Next question. What is a good practice to test if the noise sensor works like it should?
Yeah, I mean, a good practice could be if you commission a system, so to say, and in most cases, you do this maybe in a quiet situation. We all know that sound system commissioning, also because of tuning the system, measuring things, you do not want to have other noise sources. So normally you do this at night when I like my example airport terminal. So if everything is empty, you are at night there, and you may test your system, you tune the system, you level the system, etc. So you start with the silent situation, so to say. And then, of course, yeah, the only thing to test if my noise sensor works in a way how I would like to have it would be to use a noise source what you bring into the zone. So this could be then whatever, a powered speaker with a noise generator, and you just play some noise into the zone, and also here stay away with this artificial point source for noise. Stay away from your sensors, the minimum distance. So the sensor is getting, so to say, the diffuse noise, what you produce artificially now with your speaker, maybe what you use. And then, of course, when you make a broadcast, your broadcasted signal should be increased in level in a way how you want it to be. And here you can use the settings for the noise sensors in PRAESENSA, where you can define how fast should the level decrease or increase, how much should it decrease and increase. So all these parameters to how your used signal shall be influenced based on the noise source can be done in different parameters setting. And I know that my colleague Dominic Tripel did already a webinar when we introduced the noise sensor, how these different parameters have an influence on the behavior of the total system. So how the signals are influenced, well, on let's say how the used signal is influenced based on a noise change, so to say. Also there, different aspects have to be considered and taken into account.
Okay. Good. Then another question. Can you set up the total duration of the noise before the speaker will boost itself?
Um, Honestly, I don't understand the question.
Maybe
What
it
is meant
is,
with the total duration of noise?
maybe that's the sample size
So
of
you
the
mean how
noise.
fast the sensor should react? So if there is a fast changing noise and you maybe do not want the sensor to react immediately, but only after a while, if the noise is, let's say, really increasing for a longer time and not only short term, yes, this can be configured independent of the placement, what we have here in the webinar today. This can be configured with the other parameters which I just mentioned, and I'm sure that the other webinar is recorded and available in our webinar archive.
Indeed, it was the question about how fast will it respond. I just saw it in the bottom of the questions.
Yeah.
Okay, then um, can you set up the behavior differently if it is music or spoken word?
So you mean if you have a mixed application, once it is music, once it is speech, and you want to have it in a different way per signal? No, you cannot. The only thing what you can do, of course, you can choose your mode, as I said here. But if you have, let's say, not the tracking mode, but the sample and hold mode, which is normally used for speech because speech is normally not a constant signal. And the other way around, I would not see an application where music is broadcasted only temporarily, let's say, and switched on and off like a call. So I would see it more like, okay, if I want to have um, music signals distributed, then I switch the whole thing here into the tracking mode operation. Do I want to have a pure speech system or want to have influence on voice announcements? Then I should maybe go to the sample and hold mode, but we cannot use the same sensor in two modes at the same time for different signals.
Hmm. Okay. Then question, is this a unique solution or other competitors also doing this? Well, I think the ambient noise sensor concept of tuning the noise levels is something which is not unique, right? There are more companies who are doing this. I think this concept of the sample and hold option and the other option might be something which is not done by competition. I don't know if you know this, Oliver.
Honestly, I did not look into the details of competitors here now before we did the webinar, but I'm sure that competitors have their own automatic volume control solutions,
Mhm.
and how they work, how good they work, is something which would need to be analyzed in detail. Or if you have a specific competitor in mind here, maybe for a certain project where we are competing or something, then please feel free to reach out here to our, again, SBD, MKR, MKA colleagues. And then we can have a detailed look at this specific competitor. But yes, it is something which is available from competitors also.
Yeah. The one thing which we could say, which is a differentiator, is the fact that the signal which is tuning the audio is yeah, it's not audio, it's only a data signal, and this data signal is also omnio, which means it is an encrypted data signal. This is something which a competition does not have in this kind of fashion. Okay, good. Then can you afterwards compare multiple ANS with each other to see if maybe a certain ANS is overspecified slash
Mhm.
placed? Okay,
Overspecified means, can I have any kind of indication whether I could do the same thing with less ANS in the same zone, or
this is I would also read it that you have too many sensors. Maybe you can do with less. Not sure. Maybe we can get an additional hint in the chat.
or having too many ANS?
Yes,
I
here
think
comes. Yeah, if you can do it with less and learn that for the next installation.
hard to say honestly. There is also no clear indication. I think as long as you have a system which works well, let's say we have a maximum of 4 sensors installed in our zone. Yeah, and I want to be, so to say, sure, and I say, okay, let's take 4 sensors. Would it be possible to use only 3 sensors? There is no clear indication, hey, you can use only three or two only. It would be more the other way around, unfortunately. You start maybe with one or two sensors and you detect whatever that your system does not react in a way how you would like to have this. And that's maybe then because you do not cover a certain area of your zone, and you may have to use one or two more loudspeaker ANS in the same zone. But having already four, which is a maximum, and getting an indication, hey, it is already enough, you could use less. I would not know how to detect this, honestly. Although there is no indication by the system, it is in the design process. When you design your system, again, it depends on the type of noise sources, it depends on the type of loudspeakers used in the zone, it depends on the room acoustics, and it depends on how you want to operate the system, track and hold, or continuously. And all these aspects have to be considered in the design process, but there is no, let's say, fixed decision tree which I could give you now here in your hands. And then you say, okay, I take 3 or 4 times a yes or no decision, and then I end up for sure with the correct amount of sensors. Unfortunately, this is not available. There is too many parameters also maybe to be considered. So what we showed you today here is already some, let's say, guidance, what you can use to make sure that you have at least, if when you start with one sensor, to put it in the right position, in the right distance. And then, of course, if you have a larger zone, you may decide yourself, okay, but this sensor is, again, the diffuse sound field is the parameter here. So how much space can be detected as diffuse sound field with one sensor? It is, again, the sensor is omnidirectional. It has a Q factor of 1. So depending on the room acoustics, again, how much reverberation, how large is my room, you can use the same chart, what I showed here on one of the slides, to say, okay, the sensor can detect an area of that space, of that size. And if my zone, which I want to influence, is much bigger, and I would say, hey, maybe beyond this space, I see let's say, the possibility that there is a relevant noise to be considered, yeah, then I should take my second or my third or my fourth sensor into account, because the zone is simply much bigger than the relevant diffuse sound field, which I can detect with a single sensor. So, yeah, again here, as I showed it here. So again, this is for an omnidirectional thing here, depending on room size and reverberation. I can see how much space I would detect as diffuse sound, meaning here it says how far I should be away. The other way around thought, the sensor detects sound as diffuse in this space. And then the question is, what happens beyond this distance in the room? Is there any other discrete sound source? Is there any relevant noise which I need to consider? Yes, then I should go from 1 to 2, maybe to 3 sensors, whatever. So in that direction, you can start your design process when you say already, hey, I want to have 4 pieces, and they are all, let's say, far away from the sound sources. They are all in a diffuse sound field. Um, would it be possible to do the same design with only 3 being in the diffuse sound field? Maybe, yes. as long as you do not make a mistake by taking too many sensors and bringing some of them into the direct sound field, you would be fine with 4 also. Yeah, not a
Okay.
clear answer maybe, but on the other side, maybe again here giving you some indication how you could do it the other way around. Start with the room parameters, with your noise sources, with your loudspeakers to make a calculation, to make an estimation for your first sensor, and then you can go from there and may decide, okay, I may need a second one or a third one. And again, from the system side, when you reach number 4, it is a maximum what you can use anyway in one zone.
Okay. Yeah, thank you, Oliver. I think it gives additional context on what parameters to consider and how they play together if you are making decisions on this. So this is it's clearly a dynamic field, which requires yeah, a specific solution for each unique situation, I would say. There is a question here. There are many webinars for PRAESENSA, so if you want to view them, there is a YouTube channel where you can look at the PRAESENSA webinars that we did before. And also for the colleagues internally, if you are receiving the info flash, there is a link on it where you can see all the internal webinars as also the external webinars. You will find it on the training section. So there you find the full list of all recorded webinars. Then there is another question. The diagnostics in the configuration software shows a dynamic output on what the ANS sensors are doing. I think this is more a hint. So that you get an idea of what the sensor is bringing for information. Do you know anything additional about this? How this could be useful, Oliver, in context of the questions probably earlier? How many sensors do I need? Are they receiving the right input?
I, honestly, you ask a good question here, but I cannot share own experience here. I looked into these placement topic here. We did the let's say acoustic design calculations to give you some indications here when it comes to the practical use of the sensor. How useful is it to see these information here? I would refer to my colleagues who did the other webinars and may have here a little bit further insight than myself. So I'm sorry, I cannot give you
Mhm.
any comment on this one.
Okay, good. Then let me see. I think there are no further questions in the chat box. I think the time is also well filled already. So if there are no further questions, then I would like to thank you, Oliver, for giving the presentation and explaining us about this ANS sensor placement, which was very interesting, I might say. So there you put once more the slide with all the links and the different channels that we have. So I hope that we can see you next time on the next presentation. Oh, I see a hint from Anton. The diagnostics can be useful for calibration of the sensor. Anton has as a comment that's probably going down to the question or the hint from Stuart that the diagnostics can be seen in the configuration software. Thank you, Anton, for this. So if there are no further comments, then I would like to wish you all a good weekend, and I hope that we can welcome you on one of our next webinars. Thank you very much, and hope to hear you next time. Bye-bye.